Hi, I'm Tyler, co-founder of Clockwork Labs. We're a 40-person company and we're developing an ambitious game on top of a revolutionary technology we call SpacetimeDB. Just 1 year ago, we announced SpacetimeDB 1.0, a product which made it 10 times easier to build and scale multiplayer apps and games. We originally developed SpacetimeDB as the backend for our MMORPG, BitCraft Online, but quickly found that it simplified building all real-time apps. It's a real-time backend that handles server-side logic, persistence, transactions, client synchronization, authentication, infrastructure, and deployment. Since we announced SpacetimeDB, over 800,000 people watched the 1.0 announcement and started building on the platform. The reception has been amazing. In fact, since launching our cloud service Main Cloud, we have already processed over 100 billion transactions. In June, we launched BitCraft into early access on Steam. Since the launch, tens of thousands of players have explored, mined, crafted, and built lasting friendships in our world. In total, our players have collectively spent over 6 million hours playing BitCraft. Historically, MMO projects have required upwards of 100 developers to build, but SpacetimeDB allowed us to build and ship BitCraft with only 7 game engineers. This is because SpacetimeDB combines 3 key ingredients into a single all-in-one platform: server-side compute, transactional storage, and real-time networking. And it's so simple to use that there are only 3 features, one corresponding to each ingredient. Tables provide transactional storage, server-side functions called reducers provide compute, and real-time subscriptions provide networking for automatically syncing your tables directly to your clients with no additional work. It's so effortless to build with that our users consistently tell us that it's rekindled their love of game development. And today, we're bringing that experience to even more game developers. Last year, hundreds of you asked us to add Unreal Engine support, and now it's here. SpacetimeDB now officially supports Unreal Engine 5 and C++ modules. But we want to go so much further than that. SpacetimeDB is super easy for beginners to pick up, while allowing advanced developers to achieve remarkable feats of engineering. We believe SpacetimeDB will fundamentally change how we build apps. So today, we're bringing SpacetimeDB to the largest developer community in the world. With SpacetimeDB 2.0, we're coming to web. By tailoring SpacetimeDB for web, we believe it can unlock unprecedented performance and an incredible developer experience for web developers. And that experience starts with JavaScript and TypeScript. With 2.0, SpacetimeDB now has first-class support for both TypeScript and JavaScript modules and clients. Internally, SpacetimeDB uses the state-of-the-art V8 JavaScript engine to execute your modules directly inside the database for never-before-seen performance in JavaScript web applications. SpacetimeDB makes it stupidly easy to build complex real-time applications with almost no effort at all. Apps that used to take weeks of work now take only minutes. In fact, let's build one right now. We've got 9 minutes and 38 seconds left in the video. More than enough time. How about a real-time chat application? Normally for an app like that, you'd have to spend time setting up a database, an ORM, WebSockets, a wire format, a relay server, and serialization just to even get started. With SpacetimeDB, all of that is just gone. We write our app's backend as a SpacetimeDB module. A module is just a JavaScript or TypeScript program that we bundle and upload to run inside the database. It defines both our tables and our functions, which implement our app's server-side logic. Then using our powerful SDKs, clients can connect to SpacetimeDB and call functions directly on the module, or subscribe to data as it changes in real time. Let's get started by defining our tables. Here we have public tables for users and messages, each with a few fields. Once we've defined our tables, we can write our type-safe server functions. This reducer inserts our message into the table after validating the text. Reducers are functionally the same as Node.js or Bun endpoints. This is where you write all your authorization logic, but you don't have to worry about ORMs, connection pools, or even transactions. Every reducer is transactional and atomic by default, completely eliminating whole classes of error handling bugs that could put your app into an invalid state. On the client, SpacetimeDB handles your connection for you and is automatically real-time. For example, in React, a simple use table hook subscribes to the server-side state and ensures your app re-renders anytime the results change. To send a message, our client can just import our type-safe send message reducer with use reducer. Calling this function will hit our module's reducer endpoint. That's it. That's all there is. Now we have a fully functioning real-time chat app. And if you prefer something other than React, we've got you covered. We've built integrations with all the most popular backends and frameworks. But we can even get a little fancier. With SpacetimeDB 2.0 procedure functions, we can even hit an external API. Let's call the ChatGPT API right from within our module. We can have ChatGPT respond to all messages that start with /ask. But how would we do private messages? Well, let's modify our message table to make it private and add an optional to column. Now we can have view function, which returns only messages that are addressed to the caller of the view. In your modules, views are a function, but from the client's perspective, they work just like a table. This is all we need for real-time private messages. We can also query them like any other table, for example by using Spacetime SQL. In fact, since SpacetimeDB 2.0 is Postgres Wire Protocol compliant, we can just use our favorite Postgres client. In just a few minutes, we've built a real-time chat web app with private messages and AI integration. You can build the same app right now on our homepage, or get started by running SpacetimeDev. We have a whole host of templates set up for you to easily get started at SpacetimeDB.com/templates. SpacetimeDev initializes your project with a highly tailored cursor rules file, so you can just ask your favorite LLM agent to build your app for you. And it won't necessarily be slop either. SpacetimeDB improves the success rate of LLMs at one-shotting web apps like this one by as much as 15% with the latest models. Because SpacetimeDB manages all the infrastructure, both you and your LLM can focus on just your application's core logic. Once you're done, deploying to our production main cloud environment is as simple as Spacetime Publish. In just a few seconds, users will be able to use your production application. The best part is, deploying to main cloud is now completely free. With 2.0, we're announcing all new pricing for SpacetimeDB main cloud, including a generous free tier. SpacetimeDB gives you detailed insights into your usage and spending with our energy credit system. The free tier gives you enough energy to run more than 1.5 million reducer calls per month. We think most apps will never need to go beyond this. And our Pro tier, for just $25, gives you 40 times more energy per month without any additional charge. That's over 65 million reducer calls before any pay-as-you-go charges. More than enough for even relatively high-traffic websites and apps. Our Pro tier also offers advanced features like automatic replication and advanced analytics. For startups and scaling teams, our main cloud team tier offers a great option for medium or large organizations, with an even higher energy credit, the ability to reserve an organization name, and advanced developer permissions for managing teams. Sign up for the team tier at SpacetimeDB.com/pricing to reserve your organization name today. We're also announcing the limited time Space Race referral program. For the next 12 weeks, you can permanently increase your free monthly credit by up to 400 times by referring friends to SpacetimeDB. That's up to 650 million reducer calls per month, free forever. Check out SpacetimeDB.com/spacerace to learn more. And with our new web dashboards and analytics, it's never been easier to manage your app's energy usage and billing. The online dashboard provides you a beautiful interface to call functions, monitor logs, or view your tables as they update in real time. And that is just the tip of the iceberg. SpacetimeDB 2.0 is shipping with all new docs, new features like event tables, a first-party auth solution, and so much more. We even have a collection of new video tutorials to help you get started building your apps in TypeScript. We're so excited to see what you build with SpacetimeDB. There is one more thing though, isn't there? We haven't talked about performance yet, and as game devs, I like to think we know a little something about performance. So how does SpacetimeDB handle a web workload? Well, traditionally your server is separated from your database by the network. In order for your server to access your data, you've got to serialize a query, send it, go all the way through the OS stack, over the network, up the OS stack, receive, parse, plan, and execute, and then go all the way back, all while holding open a transaction and potentially locking up rows. Just pinging the loopback port on my machine without any database work reports an average round trip time of almost 200 microseconds, with a max of more than 1 millisecond. That's without even touching the network. In SpacetimeDB, your database is your server, so accessing your data takes nanoseconds instead of microseconds, or even milliseconds. That's at least 1,000 times faster. In other words, this is not to scale, this is to scale. So what does that mean for your apps? Well, let's imagine a simplified banking app. We have a set of accounts and we want to process valid transfers between accounts. To simulate a real-world scenario, accounts are chosen at random, but skewed towards popular accounts that have many transfers. Here's the code in SpacetimeDB. Let's run some benchmarks against traditional backends with 50 clients running on separate machines making concurrent requests. Newer hosted solutions and all-in-one platforms struggle. Convex, with its dozens of transactions per second, goes toe-to-toe with pen and paper. Postgres, on planet scale, doesn't offer co-location and pays the price. Supabase only manages to achieve roughly 1,300 transactions per second. But even with multiple servers, the traditional Node.js and Postgres setup tops out at 4,000 transactions per second. Bun does about 20% better. Clearly our problem is that we need something that scales horizontally, right? We need something web scale. Well, CockroachDB on a 5-node cluster only hits roughly 400 transactions per second. Distributed coordination actually slows us down, despite the much higher AWS bill. Only SQLite with its embedded architecture similar to SpacetimeDB beats Postgres. That's fun, but what does real speed look like? How fast is SpacetimeDB? Allow me to answer that question with a question. Do you like my car?